Good morning, good afternoon, good evening. Welcome to the Friday HSM Hangouts. We have a very exciting topic today with one of our partners from D3 Technologies, Nick Narzinski, and he will be going over advanced geometry selection. I'm personally excited for this. I've worked with Nick and with customers that I've sent to Nick, specifically on custom post and with some advanced support regarding the HSM technology. So I know he's got a lot of knowledge to share with the group today. So Nick, do you want to go ahead and introduce yourself?
Yeah, thanks, Matt. My name is Nick Narzinski, as he said, with D3 Technologies. So we are a reseller and partner for the HSM products, amongst many others. And we have a machine shop actually in Springfield, Missouri, so they're utilizing the software as well, doing prototype work and different aspects of machining. And then I'm on the CAM solution side, doing technical support as well as getting people up and running, post-work, a lot of the technical aspects of the software and supporting the sales side.
Okay, excellent. Do you want to talk a little bit about what you're going to go through today?
Yeah, so today we're going to talk about advanced geometry selections. We're going to be utilizing Inventor HSM for this. Most of this work you can do in Fusion 360 also, so I'll try to point that out as we go through.
So I'm gonna ask a few questions here so we can get a pulse for who's here in the hangout with us. We've got a fair amount of attendees, so I know we ask this frequently, but we've got some new guests with us as well. Have you been to Autodesk University before? And I will give it a couple seconds here. We've got about 20% voted so far. And Nick, you've been to Autodesk University, correct?
I have. Yeah, I have been there twice.
Fantastic.
And Nick has actually taught some classes at Autodesk University, so you can watch those videos online if you want.
Yeah. Go back and look. I got one on tool tips, and then another one on working with Fusion 360.
Excellent. Looks like some of the comments are saying they've already watched all the Autodesk University videos, so that's awesome. So let's close this off and see what the results are. So yeah, I mean, it looks like we've got a good spread. I mean, 20% of the people, about 20% of the people have actually been to Autodesk University in the past. 38% would like to figure out how they can make it there. So the Fusion Cam challenges are a great way to get there. I know we gave away a trip to Autodesk University for this past one. We do have a lot of people that are too busy running the shops, unable to make it, and a few people that don't like people and want to only make parts, which we can respect that.
You mentioned the Fusion challenges. We did just give away a pass to Autodesk University. I have a strong suspicion that'll happen again, and then Nick had mentioned that he taught, and I'm sure Nick can attest to the fact that your pass is covered when you're accepted as a speaker. So if there's something you think you can share with other users, that's another great way to get to go to AU.
Definitely.
Yeah, great feedback, Al. So the next question, how long have you been using HSM? We typically get a good spread here. As most of you know, these Friday webinars or hangouts are typically for more advanced topics. We also do have fast track webinars every Wednesday that alternate between turning and milling. We actually have a very even spread this week. Let me close this and share. We are a couple month-old users, some 6-month-old users, and some 2-year-old users, and a few Rob Lockwood level 70s. So, Al, do you see who the level 70s are? Do we want to give them a shout-out?
Yeah, I mean, I'm hoping that Neil Stein, I don't think enough people are honest if it's just saying 2%, because I see a Neil Stein that should definitely be a level 70. I see Seth on here that should be a level 70. Mike McCara, our documentation guy, is on the call, and he's certainly a level 70 if he can document the software. So there's more than 2%, that's for sure.
Nice. Neil's being modest, saying he's only a level 68.
Only level 68.
Okay, so the last question before we get started here, this is something that we want to get some information on you or from you on. Where do you see your shop driving future growth, or what types of aspects of your shop work do you see driving your future growth? This helps us understand where to focus these webinars and how we can help you grow your businesses. So I'm going to let this roll a little bit more. We're about 40% voted so far.
And I will say it's not just where we can focus the webinars. You may or may not know I'm a product manager for HSM, and I'm on here from the perspective of where should we also be focusing our development resources.
Yeah, and that's equally as important. Yeah. So okay. So I think we're almost at 70%. Let's get a few more people in there. Okay. So this is interesting. I mean, I don't think we've seen this type of spread before as much with 37% on the 2 to 3 axis milling. We do see a lot of focus on the 4 or 5 axis positional turning or positional milling with the mill turn and the true 4 or 5 axis. And we are getting some interest on the water jet laser plasma stuff as well.
So going
So, Al,
forward,
is that...
actually, maybe in the comments, just in case, I'm seeing 40% milling and mill turn. It'd be good to break that down and find out what of that is positional on a horizontal milling machine, so positional milling versus mill turn, and maybe that's what's taking away from that turning at 2%. So we'll maybe update the question for next week, but also in the comments if you have a strong opinion. Love to hear it.
Yeah, that's good feedback. You know, let us know. This is a good opportunity to give direct feedback to the product manager for the HSM products. So, Nick, I think that's all the questions that I had for today. I'll give you the presenter privileges, and then you can take it away from there.
Actually, just for 1 second here, I better address it because we do have a lot of new people. A lot of the regulars are making questions and comments. We've mentioned the question and comments. If you don't know, on that GoToMeeting bar that might be collapsed, you might see an orange arrow. You can send that out, and on there you should see a question section. And myself and several will be standing by while Nick is presenting, so we can engage with you, help get Nick to focus on some things if you want to, or if you have feedback you want to provide. So that on the GoToMeeting bar, there's a questions area, and from there you can interact throughout the webinar with us.
Sure, thanks, Al. And Nick, you should have presenter privileges now.
So it sounds like we have a pretty good diverse crowd here between levels of difficulty and how much they've used the software. And I was glad to see most of it was around milling also, because today's presentation I'm going to be talking mostly about 3 and 3+2, 3+1 aspects of geometry selection for milling. So as I said, my name is Nick with D3 Technologies. So today we're going to take a look at, first I'm going to start with just operation options for containment. I got a chart that kind of shows all the 3D operations in the software and how they relate to each other. And then I'm going to take a look at how tool containment works, because there is tool containment options inside of every one of those operations. Then I'm going to jump into the software. I've got 4 different good examples for techniques and how to use them and how to apply them. And I'll preface that with the examples I have. It may not be the best option for the example, but they're good examples as far as getting the point across of how to do it. And then I'm going to end with some just quick tips for those toolpath selections as well. All right, so operation options for tool containment. Don't be too overwhelmed by this chart. There's a lot going on here, but on the top you have all the different 3D operations, and on the left side we have most of the geometry selection options that are found in any of those toolpaths, along with I've added step down and axial offset. So with the red toolpaths, those are the roughing 3D operations. Those are very similar in how they work. Then you got the yellow operations, which are finishing operations, and they all work very similarly. The green ones there, those are also similar to, and they are finishing operations. However, those ones you need some type of either point for spiral, for example, or morph and project. You have to actually select a sketch or edges of the model to drive that toolpath. And then horizontal and ramp are kind of like the stepchildren in the bunch. They're a little bit different from everything else. So tool containment, which is found on the geometry tab of all these operations. Here I've just got a rectangular cube, that green toolpath, or green...
Two seconds there, Nick. A bunch of people are saying they loved your chart, so maybe as a follow-up we'll post that chart as an image on the forum.
Oh, awesome.
Getting lots of great feedback on that.
Perfect. Yeah, so tool containment here, you can see the green box is the geometry selection that I made. And then the circle will be the tool. You got the plan view up here from the top. So you can see inside boundary, it's always going to be contained inside your selection. Center on boundary means the tool can go out to the center of the tool. And then outside boundary means the entire tool can go to the outside of that boundary and be tangent to it. If you look at the elevation view, what that means with top height set to the top of the model and bottom height set to the bottom of the model, your tool will stay on top for inside tool center. However, with tool outside boundary, you're also opening up the ability for that tool to go around and down the outside of the model and be on that surface. So we're going to look at ways to get around that and how to utilize that as well. Actually, Nick did just have.
Nick, do you plan on covering on that outside containment how the tolerance comes into effect? And if not, just remind me to bring it up at the end of the webinar.
I did not have that ready to go, but yeah, we could definitely bring that in. That's a good point, Al.
All right, I'll make a note to mention it at the end.
Okay. So here I got that cube, and I just got a pocket operation on top, so that's inside boundary. Then I've got a parallel operation also inside boundary. So you can see with tool center on boundary, our tool comes to the boundary, and then we have our lead in and lead out going to the next tool path, or the linking rather. And then tool outside boundary, this is where users sometimes have trouble, is that tool path outside boundary, even though we didn't tell it to go to machine the side walls, with tool outside boundary, it is able to come down there. So let's back here. So that brings me to my first example, and using a void touch surface with the boundary selection. So in this example, we're going to use a boundary, and then we're going to use a void to ignore basically different aspects of that model. So here, we had a part set up into my vise here, and so I got a facing operation, a roughing operation, a pocket to finish that area. The last thing I want to do in this setup is run a parallel toolpath and ramp that up and down the angled surface here. So I'm going to go with parallel, come into my library, give it a second here, there we go. So I've got a half-inch ball mill. I'm going to go to the Geometry tab, and here's that machining boundary. Here's the tool containment. I'm going to go to Selection and choose that outside edge. And right now it's encompassing the entire model, so I'm going to change that to just the area I want. So I'm going to select that edge again. That puts me in edit mode, and now you can see the dark blue line. I'm just going to go through and re-guide toolpath wherever it veers off. So it veers off back there. I'm going to come through and select here. It veers off down here, so I'm going to reselect up here as well as right there. So now I've got that entire surface encompassed, and I'm going to hit the check mark to project that down. And the parallel toolpath by default goes with the x-axis, so I know right now it's going to go sideways across that ramp. I want it to go up and down the ramp, so I'm going to go to the Passes tab and change that to 90 degrees. And then I'm going to give it a fine step over, maybe 20 thousandths here. So let's just say, okay, initially with the tool set to, and I should have pointed that out, the tool containment currently was set to tool center on boundary. And it might look good in this view. However, if you simulate that out, what you're left with, let me just get my stock turned on here. And I'm just going to jump to that operation. And so what you're left with by doing that tool center on boundary is the cusp from the angle or the tip of the tool is going to leave a little radius down here at the front edge of the part. So we want to come in and get rid of and remove that, as well as these little cusps over here, because the tool can't go outside the edge of that part that we selected. So what I'm going to do is go back in there and change that to tool outside boundary. And say okay, and then you're going to run into what we saw earlier, where the tool actually wraps around the face of the part. So the final step here for this strategy is to just go in and check the box down here for a void touch surface. And then I'm just going to select those faces that I no longer want that tool path to touch. And say okay. And now you can see that toolpath does extend outside the area that we wanted. So we remove all those cuts from the front edge of the part, but it's not wrapping down, and we are no longer colliding with that fixture as well. And you can just simulate that out real quick. I'll just jump straight to the end just so you can see what the finished product looks like. And there you can see you have all that material removed and finished. So that's the first example that I wanted to show. So jumping back into the PowerPoint here. The next one is using model versus avoid touch surface. So a lot of people confuse. I get this on tech support cases quite often of people trying to select model surface to drive the geometry rather than touch avoid surfaces. So there's a little bit of confusion there on which one does what. As we just saw, how to avoid touch surfaces, that can also be used. If you check the box for touch surface, you can also use that to actually drive the toolpath. In this case, what I'm going to use is model surfaces to avoid certain aspects of the model. In this case, this U shape as well as the hole. So if I come in here to the model, you can see we have this little groove and a hole here. So again, I'm going to use a parallel operation. Let me just show a side view of this part so you can see if there is a taper to that pocket. So again, I'm going to use the parallel toolpath to run across this face here. Oops, not pencil, I want parallel. Then I'm going to come in and pick my 1/4 inch ball mill. Go to the Geometry tab. And I could use Selection here. I'm just going to pick an edge, select it again to put it in edit mode, and then select that edge there, and that looks pretty good. That encompasses that entire pocket. And I'm going to use Tool Photo Monitor this time. That should machine everything that I need it to. My toolpath is on the X, which is what I want. So next I'm going to come over, let's put a 20 thou step over there again. There we go. And now you can see what's happening here. So the tool stayed in the area well. The problem that a lot of people don't like to see is it's coming in and dipping down into this pocket, as well as the hole here. So let's address that issue first. And this is a great workflow for starting out with the software too, is do the minimum amount of changes to get a toolpath and then see how it looks and go back and make changes one at a time so that way you know exactly what you're changing as you go through. Oops, sorry. So what I wanted to use is model to avoid that area. So I could go in there, kind of like we did last time, and try with avoid touch surface and just say I want to avoid those areas. You can even go through and select each of these faces of that pocket. And there's one there. Rotate the part a little bit. Got that one, that one. So there's a lot of selection work here involved to avoid all these. Get that one. And what did I do? I might have selected the top face on accident. Oop, I did. If you ever want to deselect something, as I did here, I accidentally selected the top face of that pocket. I'm just going to reselect avoid touch surface, hold down the shift key, and select that top face. Looks like I got. I accidentally selected the model also, it looks like. See this little dotted edge around the outside of the part? That is because I selected the entire part file. So maybe I'll do is just reselect it. I'm just going to select a few faces here just to show you. It'll at least get the point across. So with that selected, the tool does avoid going into those pockets. However, it's creating a bunch of retracts and you're basically looping around. I just want to run straight across these features. So the way I'm going to do this is we're going to jump back into the model, actually. And in Fusion, you would go to the, I believe it's called the surfacing
patch.
Environment? Patch environment.
Yep.
Thank you. But in Inventor, we're just going to go to the 3D model. On the surfacing panel over here, there's a patch option. And let me just click off here to show that. You should have this window pop up when you hit that. So I'm just going to pick the circle here, as well as the outside of this pocket. And that's you want the second option there, which is tangent condition. And then I'm going to say OK. So now I've got a patch surface that goes across those features. Now with that, we did make a change to the model, so you do have to regenerate your toolpaths over here. But we're just going to come back into that parallel operation. I'm going to select the model checkbox, and now we want to include these surfaces. So I'm going to include the setup model, but I'm also going to include that patch surface. And it's going to take that into a calculation, and now, oh, I didn't turn off the avoid geometry that I had reselected earlier. So I'm going to uncheck avoid touch surface. Keep the model selected, and now that toolpath is going to run straight across those features.
So maybe I can make a couple comments here, Nick, if it's okay. First, Neil Stein, one of our level 70s, he suggested another possible way to do that, and that is to suppress the features, or you could duplicate the body and delete the features with defeaturing. So great suggestion there, Neil. The other thing I wanted to mention is this model override is allowing to add or change what model is defined, how the model is defined at your toolpathing. You probably noticed in Inventor HSM there's a checkbox that said include the initial model that was part of the setup. That's not an option in HSMWorks for HSMWorks users, so just bear in mind you do want to also select your initial model that's part of your setup. Otherwise, your toolpath could gouge that model. So a checkbox we've added to Inventor HSM in Fusion that's not there for HSMWorks users.
Great input, Al. And I think his name was Neil. On his point, we're going to take a look at that, his suggestions here in just a second also. So good input there. The next thing I would probably do in here is go through and avoid these walls. So that way the toolpath doesn't crawl up and machine those walls, because I just want to stay down here in this bottom pocket. All right, so let's jump back. So next, the third option here, which is what Al was just referencing, is creating a new model or body for driving that toolpath. So in this case, we have a chamfered edge that has some holes that also intersect it. So what I'm going to do is actually save a copy of the model, insert that into an assembly, and then we're going to basically have a model that has the holes and a model without the holes. You can also do this as a multi-body model. So there's a few different ways to get to this. In Fusion, you might just do a copy of the component and put it right back on top of itself, and then you can modify the copy. In here, I'm simply going to copy the model, start an assembly. And I guess before I do that, I'll just show you what exactly is happening. So I've got the board to bore those holes out, and then I've got a contour operation. The problem is the contour is following the geometry of the model, right? So it's coming into those bored out areas, and I just want to run straight across it almost as if they didn't exist. So to do that again, I copied the model. And there's a few ways to do this. You could just do a place component into an assembly also. Or as I said, you could do a copy of the body, place it back into this assembly, and then remove the holes of one and keep the holes of the other. But if you think about it ahead of time, you can just place this into an assembly. And the first component you place in there is grounded. I'm just going to keep that one there, And then I'm going to go up to this productivity drop-down. Actually, let me paste one more of these in here. So I've got 2 of them in there. Then I'm going to come up here and say ground and root component. That just laid one component right on top of the other and grounded and rooted into the same position. So you don't have to go through the process of constraining or adding a joint. It automatically grounds it and roots it at that position. The next thing I'm going to do
That was a nice little CAD trick. Good job there, Nick.
Yep. And so the next thing I want to do is they're both the same component at this point. So the next one I want to do is save and replace component. This is going to no holes. This just replaces that component inside the assembly. So now I've got 2 different models in there stacked right on top of each other quickly and easily. So now I can either, what I'm going to do is keep the original, just turn the visibility off real quick, and now I will be only editing that second version of the model. So to do that, it's probably best to double-click the model and actually edit the model itself, not the assembly. So I double-click it, and I'm just going to go through and do a direct. I could open up the part and delete the feature as well. Well, actually, let's just do it that way.
It'd be good to show both, Nick. So there's the deleting the features, but the other thing I love that you mentioned is how you can put a part in an assembly. And I think it's a good time to mention that's often a great use case when you're working with other people's files, because as Nick showed replacing the model, if you're working with an outside vendor that sent you the file and they changed the file, if you toolpath it in an assembly, then you can change the underlying part file and a lot of your work stays intact. So programming in an assembly is often a very good thing to do for other reasons also. Yep,
good point. So here, this way, you could either suppress or delete the feature of that model. And the reason it's easier to go in and do that rather than try and do it on the same file is you don't have to go through and protect and then go back and change the model and then go through and reprogram on the same model. That oftentimes will get you into some trouble. So it's best to have 2 different files or 2 different bodies.
So now that you mentioned it, Nick, let's dive into that one because a couple of people are saying we should have brought it up. What Nick was saying on that protect was that if you don't want to create a bunch of duplicate bodies, you can actually suppress the feature, update your toolpath, and then you can right-click and protect, which locks it from any parametric updates, and then add the feature back in. So you lose the parametrics, but it gets you the toolpath you want. So if you just right-click any operation, say protect, then it's not going to update when your model changes. So you can make a modification to your model, generate a toolpath, and then make the change back to your model and have that protected toolpath. It is a separate workflow that Neil and some of the other level 70 stuff we should at least mention.
Yep, exactly. Just to show that real quickly, I just protected this toolpath here. If I want to double click that model, and this will be a good way to show direct also, I can just select a few of these things, hit delete. It's going to delete whether it was created in Fusion or whether it was created in any CAD file, because Inventor opens up just about any file type. So you open that up, and you can delete that feature or suppress it, as Al said. Actually, that's what I wanted to do. Kind of got off topic there. Suppress that feature, and then you can go on and model the rest of that as if it was there. But when you go back to the CAM environment, it doesn't, the toolpath will stay there because it was protected. So, good points. Let's see. So in this one, I suppressed that feature on the second model, and then you can jump back to the assembly, and now you can go ahead and start your setup. So I'll just do a setup here. You do want to make sure that you select the finished model in this case, because right now it's going to select everything that's in the assembly. So I cleared that model. That's an important part. And then I'm just going to jump back to the model browser and select turn visibility on. Okay, so I'm going to clear that and just make sure you select the one with the holes as your setup. And I'll keep the rest of it as default here. Say OK. Now you could go through. You've got two different bodies there. So you can turn the visibility of one off and leave the other one on. So I could go through and bore those holes out and then follow that up with contour, for instance. So let's just grab a 1/2-inch end mill. We'll keep it at silhouette and see how it looks here. So right now, it's going to go into those pockets like we said. What you'll want to do is turn on model, and then you can select the surfaces of the model.
As another option, you can just select that whole separate body too.
You could do that also, correct.
Yep. So it wouldn't be as many selections. So what's happening here, and I can explain why, is the what this does is it's an override and it adds new to it. Well, it's because you still have your initial model selected, so you need to not include the initial setup model. And now the other thing that's interesting here is because you selected surfaces, that's showing it is an override and it ignores everything else that's not selected. So if you unselect use a setup model, then the only thing driving it is these new model override surfaces.
Great point. Yep. So now we're only machining that portion, and then the next step would be just to go back to the model and turn that model off, and then you can go through and program the board holes for the rest of it, and whatever other features you may have in your model. So there's a few different ways to do that, but you just have to find the one that works best for you. All right. How are we doing on time? We got about 25 minutes. Okay. So next thing I want to do, and this is more for the 3+2, 3+1 crowd, is using planes for indexing. And then you can use silhouette for that model, and then use a combination of heights, touch surface, in order to decide where that toolpath is going to machine. So in this case, get the right part file here. And you guys may have seen this. Al, where was this? Was this done on Titan?
Yeah, Titan did this, I think, in season 2, was it? Maybe season 1. It's probably available as a video.
Yep. So here we have, I got 4 of them done just off of the planes. So you got a roughing for one side, for another side, basically all 4 sides. You got those roughed out. In each of those, I have, if we look at the toolpath here, I'll just unprotect that one. You can see here I have a geometry selection, and then I also have rest machine turned on from previous operations. So each one is referencing the previous operation, so it knows what's already been removed from the stock down to the model. So the next thing I want to do is kind of get some different angles to machine on this part. And to do that, I'm going to jump back to the model and actually create some reference planes to index off of, and then we can come down and machine that part. So again, going back to the model, I'm just going to create a plane here and open up my origins. I'm going to find the XY plane, and then I'm just going to drag that up, find kind of the center of the outer limits of that model. There's no need to be real exact here. Next thing I'm going to do is create a sketch on that surface, that plane that we just created. And then I'm going to come in and use a polygon, kind of find the center of mass here. And I'm going to use 6 different edges. So I'm just going to drop a sketch on there. And the next thing I want to do, let me just rotate this model a little bit, is we're going to create a surface extrusion. You can do this in Fusion as well, creating these sketches and then using a extruded surface. If I can hit the hover, there it goes. So for the output, you don't want it to be solid. I just want to do a surface here. And this isn't real critical. I'll just put 4 inches. The thing I do want to change here, though, is if you go to the More tab, you can put a taper angle on this. Let's try negative 30 degrees. So I'm basically creating a bunch of surfaces that I can go through then and index off of for that tool orientation within inside of each operation. So I'll turn the visibility of this one back off, jump back to the cam. So this is great for you guys who don't really want to get the simultaneous 5-axis machining. A lot of machines can't handle that real well, but this is a great way to do surface work if you just want to lock it into a certain orientation and then come down and do 3-axis machining. So back to the cam tab, I'll do a 3D adaptive operation. This time we'll use a 1/4-inch ball. So this will be like a semi-rough type of operation. So we've already got a good roughing operation in. Now I'm going to do a little bit, just knock off basically the edges of that. So I'll keep this to silhouette so it stays within the model. I'm going to come down to tool orientation. Select one of those faces. And then we have rest machine from setup. I'm going to change it to from previous and from the setup stock and say OK. So this will take a little bit of time to calculate just because it's got a lot of previous operations to look at. But you could just repeat this process basically for each of these angles. And each one's just going to machine what's left behind from those previous operations. Here's an example of it done already. So you got your rough operations with a large cutter. I did a semi-rough with the ball mill. So you can see we're just indexing going around that part using the silhouette operation or silhouette for your geometry selection and then rest machining from previous operations. And then I finished it up with just a scallop to go around with that ball mill with a real fine step over, and that gave us our finished toolpath finish, our finishing surface finish. Well, one thing I didn't do, so I talked about it in the slide, but I didn't actually add it to this operation, is changing the heights. So I don't want it to go all the way to the bottom of the part because I've got, better angles that I can do. So I'm just going to come into the heights and drag that bottom height up. What's real nice about this workflow is you don't have to be exact on where you position the planes or your indexing, because with that rust machining, it's always looking at the previous operation, so you're not going through and recutting there, basically. And this is probably a good point. I'll talk about how good you guys did with the software and using the 64-bit operating system. You'll probably see on your computer that you guys are getting 100% of your CPU flawless as calculating. And there you have it. So you just go through and repeat that process with a bunch of different angles, and it'll give you a great surface finish on this model. And then the last thing I have here is just some quick tips for finished toolpath selection. Derived toolpaths are a great way. And remember that chart that I showed earlier. Ones that are very similar, you can use the same geometry selection and just create a derived operation for each one with different types. And then go back and look at it and just see which one you think fits the model the best. And then the other thing that I wanted to show was templates. You can add notes to them so that you can remember exactly what you had to select. And I'll just show that real quick. In the slot here, I have a part with a slot going all the way through it. 2 of them, actually. So I've already created the operations. And what I did Well, I've got the counter selection to the bottom corner. And then on the heights tab, I've got the top height select. Oh, what happened here? Let's take a look. Maybe it was this one. There we go. Inside of here, I've got an expression that says tool fruit length minus maximum step down. So what that ends up doing is giving us a perfect step down value between what you selected and for my top heights. So let's say I didn't remember how, or I wanted to remember and reuse that quite often. You can right click and do edit notes here, and you could just type contour selection equals bottom of slot, and then I might say top height equals top of slot. And then I can right click, store that as a template. Let's call it slot, save that. And then your next part, or next time you need to use it, I just right click, create from template. There's my slot operation. Initially it's going to come in. We need to make some selections for it. So I'll go back to that edit notes. Maybe I did this, a few months down the line. Now I'm going to remember exactly what I needed to do to get that operation to work correctly. So counter selection and the top height. So I'm just going to go back in there, select my contour selections, and then pick a top reference. That's a good tip there. This is one I haven't used in a while, obviously, but you can just go in there and edit notes. That way you have a good reference as far as what you need to do to get that toolpath to work correctly. So what kind of questions do you have, Al?
Well, I'm seeing lots of wows and loves it. There's a question, is there a plan to allow templates to be sorted into folders? Yes, so it's a separate idea, Frank, but yeah, we're very aware of a need to have better management of templates. I think it's a little bit of an aside from this topic, but I'm glad you brought it up. I did have the one other topic that I wanted to mention from the very beginning. So maybe if you could just pull up your slideshow and go back to that containment boundary thing. I want to talk a little bit about those containments, just to make sure no users get caught by it. Yeah. So the thing I want everybody to be careful of is just to keep in mind that tool outside boundary. It is very powerful. The thing you want to watch, sometimes you might get a right result where it looked like you contained the tool and didn't allow it to waterfall over the edge of a part. And then you might do something like change a step over and notice the toolpath waterfall over the edge. And what I really wanted to tell you is this is based on the tolerance of the model when you calculate the toolpath, because that containment is a very accurate bit of geometry, but then your model is toleranced before the toolpath engine gets it. So you could end up with a kind of a triangle in the tolerance of maybe 4 thousandths of an inch or something, where the toolpath can kind of sneak down in through and waterfall over your part. So it's a good habit with that tool outside boundary to use an offset value from that. I don't know if you hit on it, Nick, but you can use tool inside, center, outside, and you can apply a positive or negative offset. When you're using tool outside boundary, just a strong suggestion to reduce from that or add to it the tolerance of your toolpath. Hopefully that makes sense. If there's a bunch of questions in regards to that, maybe we should do a post on the forums or something to help people with that.
Wait, is this the tolerance you're talking about in the toolpath, Al?
Yeah, so the toolpath tolerance. So let's say you had a round part. That toolpath tolerance is going to basically triangulate the model. The underlying toolpath algorithm is happening on a triangulated model. So it's going to triangulate the model. So if you can picture a circular part with a stop sign shaped circular containment boundary with a stop sign shaped part in the middle of it. You've got these triangular shapes where the toolpath could kind of sneak in based on if there's a toolpath in the middle of that triangle. It's kind of hard to describe without a picture, but I most importantly wanted to make people aware of that, so you don't change a step over, repost, forget to take a look at the toolpath, and then possibly end up with a problem. So the other thing is there's a lot of questions coming up from the patching, and is there other ways to go from one point to another? I loved how you showed the different areas of CAD. I think it's been a theme for the last couple webinars, but I think it's often missed when people start using an integrated CAM system. They immediately forget that they're inside of a CAD environment. And maybe it's because they don't want to dirty the CAD design, which is a fair point, but you're forgetting of the full power of a CAD environment. So that's where some of the advantages you showed, Nick, where either you put your part inside an assembly, so you have a clean but associated area where you can make changes to the geometry without affecting the original design, or you insert the part into a base part and then start adding on top of it, but still have your associativity. So there's ways around not messing up the initial design that the engineers are working on, but still giving you full access to the CAD environment. So I want to make sure our questions aren't from the perspective of, well, I don't want to mess up the CAD file. Just put it in assembly, put it as the base part inside another part, and now you have the full power of a CAD environment to do things to help you manipulate and drive your toolpath. That's a strong advantage to an integrated CAD system, CAD-CAM system that I think is often forgotten about or missed.
That's a great point. Actually, one of my favorite things about that with Inventor and Fusion, I guess you can make a copy of the model, but Inventor, we have the derived component function. And basically, if you start a blank file and go straight to derive, I can come back and pick, let's just use a cube, for instance, that I started this webinar with. And this is the option you want here, is maintain each solid as a body. That basically starts a new part file that is referencing the original. However, any changes that I make to this model are not going to affect the original. However, then, let's say the engineer who designed the model comes in and says, well, we need to make a change to that model. You can make the change, whatever it may be. I'll just grab a face and move it. So the engineer makes a change to the model and saves that. When you go to that derived part that we just created, we get a update lightning bolt here. All you got to do is click the lightning bolt. That model updates to the original. However, you're never going to affect where it came from. So that's pretty powerful tool right there.
Earlier question you had in the webinar too, where do you maintain that associativity when you're defeaturing a part? So again, I mean, I find it personally very powerful to work in the derived part or to work in assembly, because it sort of gives you the full parametrics but segregates you from the engineering data. So it might be the engineer does a save as and designs a new part that was based off of the first part. Well, now you can replace it. It might be that your third-party vendor sends you a new parasolid file, and now you can replace it and not lose all that effort you put both to the CAD and the CAM side of getting ready to actually machine a part. So again, great presentation on that. For our SolidWorks users and HSM Works, for the Inventor users and for the Fusion users, this is something all of you can take advantage of. It's slightly different in each CAD platform, but the idea of a base part or body is available in all three of those products. I do see a question in regards to broaching. If you search the forums, I believe CJ Abraham, one of our guys, did a post on there showing how you could hijack a drilling cycle to do broaching. We don't formally support it, but you can hijack a drilling cycle and do some post-processor modifications for that. And then along the same lines, there's some people asking about the videos. Some of these webinars, the videos are helpful. Others, I'm sure, are confusing to follow along with after, because we do try and keep these to be an open and engaged conversation. But all the videos are posted on the YouTube channel. Wayne usually gets those up by the end of the day. So there's a specific playlist for all these weekly webinars. Well, with that, Matt, maybe we should turn it back over to you. You can wrap things up for us.
Yeah,
if the questions continue to trickle in, we'll answer, but thanks again for a good join.
Yeah, Nick, thanks for that fantastic presentation. That was really helpful. Lots of engaged attendees to the Hangout this week, and Al, thanks for all your input as well. Okay, so I guess the one thing that I wanted to bring up here was, the HSM group's got a lot of events going on across the U.S., in addition to these Hangouts on Fridays and the Wednesday webinars for the Fast Track. A couple that we have coming up next week in Southern California, we have an HSM and Fusion 360 CAM Fast Track, and that is in Anaheim. And all these events are available on fusion360.autodesk.com/events. Another one going on next week is in Denver, Colorado. I'm actually located personally in Denver, Colorado, and that will be in the Autodesk office that we just moved into back in July. And that will be a Denver CNC meetup, actually, in addition to a topic focused on what Fusion 360 can do for you. So these are some of the topics, that the HSM group will be in attendance at coming up. There is another one you can see here in Fairport, New York, on the 22nd of March. That is another Fast Track event. That is a hands-on event. So I wanted to make everyone aware of those. And then for any questions or anything that pops up, my contact info is on here. My name is Matt Snitowski. I'll be taking over these Friday Hangouts along with Wayne Griffenberg, who's an application engineer. He's online answering questions in the chat window along with Al and the others. So there's a lot of moving parts and a lot of people involved in these Hangouts that make these so successful. So if you have any questions, comments, feedback, concerns, future topics for webinars, or you'd like to join us and host a webinar with us, feel free to reach out to Wayne or myself at this contact info here. And I think with that, everyone have a wonderful weekend. It is Friday, so thank you for joining us, and we look forward to seeing you next week.
Good deal. Thanks, guys.